All right, so let's actually try some buffers. So if you want to pause here and write these down and then try them out, I'm going to go over the answers in just a second. I want you to come up with 3 ways to create a buffer with this system here, and then 3 ways to create a buffer with this system. So this obviously is a weak acid, this is its conjugate base. This is a weak base and its conjugate acid. All right. So hopefully you can pause this and get a chance to do it on your own. I'm going to go over the 3 ways that you would make a buffer with acetic acid and the acetate ion. So the first and easiest way to create a buffer is going to be to add in, so we're going to assume everything is 0.1 molar, okay, in the whole video. Everything is 0.1 molar, so I don't have to keep writing it. I'm going to add in 50 milliliters of the acid, HC2, and I mean, you can add in 50 mils, 40 mils, it doesn't matter, however much, just generate around the same amount of a salt. So I'm either going to start with K or Na, containing the conjugate base. Okay, so this would be one buffer for this system. Another buffer for this system would be if we started with 50 mils of the HC2O3O, and to this we're going to add base, okay? And when we add base, a strong base, we're gonna cause a chemical reaction. And we only want to do this with half of it because we want to leave half in the acid form. So we'll add in 25 mils. Could it be 20? Sure. Could it be 10? Sure. Any amount would work. Okay. So now we're going to add in NaOH. And what this is going to do is it's going to cause a chemical reaction between the weak acid and the strong base. And when we add the strong base, we get rid of the Na. This is going to go only in one way, okay? And when we do that, okay, we're going to end up with, and I'm going to run out of room here, the conjugate. I don't know where that line came from, sorry. O2 minus, and we generate water. We don't really care about the water. So now we have the conjugate base, and we have the acid. And because we've only used up half the amount of acid, some of the acid is left and some of this is formed. This will get used up in the chemical reaction. So all you'll be left with is your weak acid, your conjugate base, and that's what makes a buffer. All right, the final way to make this buffer system would be instead to start with the salt. So we would start with NaC2H3. So this would be the salt, okay? And to this, because this is a conjugate base, we would add in half or so the amount of acid. And we're going to use a strong acid. The HCl, HNO3, all of those would work. So now we're going to come down here. I'm going to get rid of the Na because that's just a spectator ion. So we'll start with our conjugate base, and to that we're going to add a strong acid. Reaction is only going to go one way because it's a strong acid. It's going to be H. Okay? And that's going to form our weak acid. Because we only used half of the amount of the H+, all of this will get used up. So you're going to be left with some of this and some of this. If you have a weak acid, its conjugate base, that's what's going to make a buffer. All right, so let's go back to this here, and we're going to do this example problem now with the weak base. All right, so we have here our weak base, we have here our conjugate acid. We need to get both of those into the same solution. So let's mix in 100 mils. Again, everything's 0.1 molar just to make life easy. Again, I'm just arbitrarily choosing 100 mils. So you can make a liter, you can make 2 liters, whatever amount you want, of CH3 and H2. So we go get that out of the stockroom. That's a solid. We add it into the water. And now we've got to go choose how we're going to get this into solution. That doesn't exist by itself because it would have a positive charge, and you can't make a solid out of something when everything's positively charged. So this would have to be in the form of a salt. So we would have 100 milliliters of CH3NH3. Since this has a plus charge, we need to match it with something that's minus and something that's not going to cause any changes in the pH. So I'm going to choose Cl. I could have also chosen NO3. Any salt that is going to, any anion that's going to create a salt that you're going to have a spectator for the anion. All right, so another way that we could make the buffer would be to start with 100 mils of the CH3NH2, but instead of adding in the salt, we could add in half the amount. Does it have to be exactly 50? No, but some amount of the strong acid like HCl or HNO3. So when we do that, some of this is going to react, and some of it is going to stay in this form. With the strong acid, reaction arrow only goes one way, CH3 and H3 plus. So that forces it to make the conjugate acid. And we have here our weak base. We have a weak base, it's conjugate acid. This is a buffer. The last way that we could make this would be to start with the salt. So for this salt, I used NO3. And we know with the salt, the NO3 is just a spectator, so that's going to leave us with a positively charged, that's a plus, not a minus. There we go. All right, ion. So if we're starting with a positively charged ion, we know that's going to be a conjugate acid, okay? And if we want to turn that conjugate acid back into its weak base, we're going to need it to force it to do that. And the only way to force it to do that is to add in a strong base, and approximately half. Again, it doesn't have to be exactly half. And it's 0.1 molar because we just decided everything was 0.1 molar. So when you mix the two of these together, you're going to have a reaction that takes place, and the OH minus, Na plus is a spectator, is going to reform this into the weak base. Okay, so now all of this in the reaction will get used up. So what you're going to be left with is going to be your conjugate, that is a weak acid, but we'll label it conjugate acid, and weak base. If you have two of these in similar concentration, that is what makes a buffer. In the next podcast, we'll learn how to calculate the pH of a buffer.